All right, so this, we are going to be talking about zero exponent and negative exponent. So in your journal, put zero or negative exponent. And there is a rule to dealing with zero or negative exponents that you need to always remember when you're doing this math. The simple rule for a zero exponent: any number except zero, oh, here's the worksheet online. Any number except zero raised to the zero power is defined as, does anybody know? You would have seen this one time in like 6th grade. Remember? So any number, like 1 to the power of 0. Okay, when I'm dealing with an exponent, what does it tell me to do with the base number? It tells you how many times to multiply it, right?
Yeah. Just be the number.
So in general, you would think it would just be the number. However, the zero exponent has an exception rule. Any number to the power of 0 is always 1. So put that at the top of your paper, defined as 1. So if I have 1 to the power of 0, what is it? 1. If I have 2 to the power of 0?
2. Wait, 1.
1. If I have 3 to the power of 0?
1.
If I have 4 to the power of 0? Hello? What's 4 to the power of 0? What is a variable to the power of 0? 1. Okay? So that is the rule you just must remember. Anything to the power of 0 is 1. The only exception to that is 0. It cannot be 0 to the power of 0. Okay, this is not. Cannot.
Pretty sure there was actually an SAT question that had that question on it, and the answer was actually found to be 1.
Interesting.
So, yes, it used an algebra rule. I forget which one it was, but yes, it is actually 1.
I'll have to research that. According to the SAT question. But remember, SAT questions are written by humans. All right, everybody have this?
Wait, so how come 0 can't, like, 0 can't be the
I don't have a mathematical answer for that. That's just the rule I've been taught since I was y'all's age. But according to Liam, it's changed. So I will research that and find out. Fortunately, for your papers, they're not going to give you 0 to the power of 0. You're not going to have that in anything I give you. So, all right. Questions on zero exponents, other than Miss Cease has homework. All right, so now let's talk about negative exponents. So there's a rule I want you to write in this little box right here. If I have x, which is your base number, to the power of a negative exponent, okay, you cannot have a negative in the exponent and consider this a simplified equation. So in order to get the negative out of there, you have to put this whole thing under a 1. So x to the power of n. And again, x cannot equal 0 for this rule. Okay, so that's what's in the box right there. So let me show you an example. If I have 5 to the power of negative 2, how would I rewrite that to simplify it? Can't have a negative exponent. I need to put it under
1 over 5 to the power of 2.
1 over 5 to the power of 2. Okay, so all we did was rearrange it to be underneath the denominator line, essentially. And then to simplify this, now we just do this. So you have 1 over, what is 5 squared? 25. So then this would be your final answer.
Wait, what is, do you mean by 5 squared? Like,
5 times 5. That's what we did yesterday.
Why did we take away the negative number?
Because you can't have a negative in the exponent. Okay. So when you move it below that line, that takes away the negative. Okay. It's like when you cross the equal sign, you know, when we're solving for equations, you're changing signs by adding or subtracting, multiplying or dividing. This one, you're crossing this middle line, which changes the sign. You can do the same going the other direction. If I have 5 to the negative 2 on the bottom, I can go above the line. It becomes 5 to the power of 2. All right. What if I have 8 to the power of negative 2? First rewrite it. What would I write? Logan?
1 over 8 squared.
Okay. And then simplify it.
1 over 64.
1 over 64. Because I did the 8 to the power of 2. And 8 times 8 is 64. Reminder on exponents. It's the base times itself, however many exponent number, if it's 2, it's 8 times 8. Question, Logan.
Will you always use a 1 and then...
Yes, it will always be a 1 on top.
So if it's 1, would you just do 9? Would it just be 9?
Yes. So number 17, if I have 9 to the negative 1, how would I rewrite that?
1 over 9 to the power of
1 over 9 to the 1. Well, base number one time is just that base number.
1 over 9. So if it's ever like a negative 1 and then it's just a 1 and then that 1 whole number?
I did not understand what you asked. If it's a 1 and you moved it to the bottom, then all you had to do is make it to the bottom of that, and then it's the whole number, the base. Is that what you said?
Yeah.
Okay, then yes, to answer your question. All right, so now you're going to do those by yourself. Let's go to number 21. Okay, so this is 21. Don't forget to go back and do the ones we skipped. If I have 4 to the power of negative 3 times 7 to the power of negative 1, first step is to rewrite this without the negative exponent. So how would I write the first term?
1 over 4 to the power of 3.
Is he right?
Yes.
Okay. Times, and then how would I rewrite the second one?
1 over 7 to the power of 1.
Which is just 1 over 7, right? Okay, so now we need to do this math. What's 4 cubed? Why don't I want to export? No.
64.
1 over 64 times 1 over 7, yes? Okay, when you're multiplying fractions, 1 times 1 is? 64 times 7 is?
48.
Good job. Make sure you pay attention to what the instructions have told you to do. It says to rewrite each expression using positive exponents, which is what we did here. Okay? And then evaluate. And this is where you're evaluating when you get the final answer. All right, any questions on how we did that? Okay, so now you can do 22, 23. Let's do 23. All right, so 23, I have 3 to the power of 4 times 9 to the negative 2. So how would I rewrite this?
3 to the power of 4 times 1 9 to the power of 2.
3 to the power of 4 does not change because it's a positive exponent. So now I'm just saying times 1 over 9 squared, right?
Mm-hmm.
So now let's simplify that. What is 3 to the power of 4?
27.
We have two different numbers.
wait.
3 times 3 times 3 times 3 would give you 81.
Yeah.
Times, what is 9 squared? Hello?
81.
Okay, 81.
81.
All right, and now we multiply straight across, which is the whole number over an imaginary 1, right? So I get 81 over 81, which is just 1. Right? Any questions? It's open notes, open friend. Not open AI. All right, any questions on this one? Not too bad, right? So you only move it below the denominator line if it has a negative exponent. Otherwise, you leave it on top. Shh. Okay, I need you to whisper algebra. Question, Lexi.
I don't know if this is like a bad question, but
How would we know when to not make like that type of number until 1?
Which number? This one?
No, 3 to the power of 4.
How do you know when not to make it a whole number?
Yeah.
You're always simplifying. So if it tells you to evaluate, I want the answer. If it just tells you to make it positive, then you would stop there. But 90% of the time, you're going all the way to here. So you're solving it all the way. All right, let's do 24, just because it looks hectic. It's really not bad, but... Okay, so we got to simplify these 3 expressions. How would we simplify the first one? 1 over 8 to the power of 3. Does everybody agree?
Yes.
Correct. 1 over 8 to the power of 3. The second one, what do we need to do to that one?
Nothing.
Just leave it 10 to the power of 2. What about the last one?
Times
1.
4 to the 0 is just 1. All right, now let's evaluate. What is 1 over 8 cubed? 8 times 8 times 8.
512. Okay.
Very good. What is 10 squared?
100.
This whole thing times 1 is just going to be whatever this whole thing is, right? So I can leave the 1 off. All right, so now we multiply straight across. This is a whole number over 1. So I get 100 over 512, correct? Can I simplify that? All right. Yes, it's even numbers on the end, right? 0 and 2. So at minimum I can divide by 2, but I think I can divide by 4. What do y'all think?
4. I think so too.
Put it in your calculator, 100 over 512, and hit enter and see what happens.
25 over 1.
I heard you, Julie.
25 over what?
128. So make sure you're simplifying. Remember, if you don't simplify, you lose a half a point. Oh, don't let me forget to give you back your quizzes today. All right. Everybody got this one? All right, now we're going to do number 25. We have x to the power of negative 9. How do I simplify this?
1
Say it louder, Julie.
1 over x to the power of 9.
1 over x to the power of 9. Is she correct?
Yes.
Is there anything else I can do to this?
No.
You're done. Simplify. Okay, let's do 27. I know y'all can do 26. All right, so 27 is r to the negative 6, s to the 0, and t to the 11th. All right, so let's simplify each expression here. Caleb, how do I simplify the first one?
1 over r 6
To the 6th? Okay, is he right?
Yes.
Good. Bella, how do I simplify the second term? S to the power of 0.
1.
Correct, so it's just times 1. Logan, how do I simplify the last term?
Yes, stay the same.
It stays the same because it's a positive exponent, t to the 11th. All right, 1 times all this other stuff is just all the other things, right? So I could rewrite it without the 1 in there. So I have 1 to the r6 times t to the 11th, technically over a 1, correct? Because that's a whole number. So then I get t to the 11th, ooh, that's a crooked 11, over r to the 6th. Okay, they have different bases, right? T and R are not the same letter, correct? T and R are different, so you can't simplify this any further. If they were the same base, we could, just so you know, but we'll do that on the next lesson. Since they're different, we're done. Okay, any questions on anything we did today? I think I've hit all the examples. So you have, what, 5 or 6 you need to do on your own?
Yeah.
That is it.